And we stopped last time at the beginning of this random variable. So we said that the random variable, so today inshallah we'll continue with the definition of the random variable, and then we'll talk about how to describe the random variable in a more mathematical, concise way. So the random variable, as we defined it, is basically a mapping from the sample space elements into from the sample space element into what is math? Into a real line, right? So we said that we take every sample space point and we map it into the real line. So basically, in this particular example, we are twisting the coin 3 times and we are marking the number of hits, right? So in this case, the number of hits, for example, how many outcomes we have in sample space? In this particular example, 8, right? So basically, we expect that every one of them will have certain values. Now, 2 of them can have the same value, right? However, 1 of them cannot have 2 different values. زي ما شرحنا هنا. X, if we have a دالة على X, basically Y in terms of X, you can have, for the same X, you can have only 1 value of Y. But you cannot have دالة شكلها كده. This is not a valid function. So, for example, here, the number of heads, the random variable describing the number of heads. For this particular outcomes, the number of heads is 3, the random variable value. For this particular outcome, the random variable is equal to 1 because we have 1 head. For this particular outcome, the random variable value equals 0. What about H, P, H? Where to map this? Into 2. What about H, 3 hits? Where do we map it? Into 3. And so on. Okay, so basically the domain of the random variable is what? The sample space is the element, is basically composed of the elements of the sample space. This is the domain, this is where you get the values from, and the image of the domain will be a subset of the real number. So basically we call it L6, and this is the range of your random variable. In this case, what is the range for this particular example? X equals 0, 1, 2. Can it take 5? Can we have 5 hits? Can we have -2 hits? So basically, this is the range. Okay, and we define the random, or we denote random variable as in here. It's x of s. Okay, it's x of s. X of s here is basically S belongs from the sample space. S belongs to the sample space. And X of S is random variable value of S. Okay, random variable. When you say when we see argument this class, from now on means random variable. Any question about the definition? How can we, what does a random variable mean? So by here, if I give you a sample space that looks like this, now regardless whether this represents the number of heads or another experiment, now we can study this random variable. We see its distribution and other parameters, in average, and other basically parameters that we can use. Just 2 examples before we go into more about the random variable. So this is very important. And everything from now after that will depend on this question. And I'm not exaggerating. Everything after today, everything that we talk about is about random variable. Random variable distribution, random variable density function, random variable mean, random variable moments, random variable characteristic function, random variable functions of random variables, and so on and so forth. After that, when we talk about the random process at the end of the course, the random process will basically can be described as a single time. So you need to understand the concept very well, please, if you have a question. Now, another example, basically we are pressing a coin and rolling a die. And we said we define, it's my definition. You can define another random variable. It's up to you. One definition of random variable would be if it is hid, then the random variable will take the corresponding number that appears on the die. If it is tail, you will have the random variable will take twice the number of the that you see on the die. This is one random variable. You can define another. So you can see that here this is just a pure mathematical random variable that maybe doesn't make sense. However, in others, you will find that method, and I can define another, for example, for the example. I can define a random variable that if for those students who get above 50, above average method, and those students who get below average. So in this case, I can define the random variable as 1 if you are above average, and 0 if it is below average. Method 1 means pass, 0 means fail. That's it, not necessarily. 1 means probably good student or good performance. 0 means a little bit below average performance, and so on. A third example here is the wheel of chance, we call it, where basically there is a wheel with certain numbers from 1 to 12. So in this case, S equals coming S basically 1. It's discrete numbers. 1, 2, up to 12. That is like it's not basically ordered. These numbers are not. So in this case, you can see that this is S. It's 1, 2, 3 up to S. Now, in this case, you can map the number, the random variable defined as whatever the number that you get square. This is a random value. You can define your own random value. Okay, you can define, for example, XS as absolute value for this square. Okay, it's 2. It's whatever. واضح يا شباب؟ أي سؤال؟ Why did we do X is a square? Just an example. Very nice. يعني this basically particular example very nice. مثلا let me move on and we get more information, more examples out here. طيب, these are the conditions of a random variable. تكلمنا عنها. Random variable cannot be multi-valued. So basically, this is what we mentioned here. One element cannot take 2 values. One sample element is mapped into 1 single value. 2 sample elements can take the same value. But not the other way around. 1 element cannot take 2 values. This is the first thing. It cannot be multifunction. Now, this is the condition. The rest are basically characteristics or properties. You can think about it. Now, if I ask you, what is the probability that X is less than a number? خلينا ناخذ الهيد تذكر number of heads. Percent. Coin. Number 3 times. Number of heads. So basically, what was the sample space? Sorry, sample space, you have 8 elements. What was the values of X? XS is the number of heads. ايش كان السامبل range of the sample space? 1. Can it have 0? 0 heads, 1 head, 2 heads, 3 heads, right? What is the probability of 0 head? What is the probability that X equals 0? 1 over 8. Why is it 1 over 8? Yeah, it's basically the probability of the corresponding elements in the sample space. What was the corresponding element? Tail, right? 0 in the random variable space is equivalent to tail. So this was equal to 1 over 8. Happens only once out of 8 possibilities. What about probability of x equal 1. ايش رايكم؟ 3 over 8 because it's equal to how many times the random variable can take 1? 3 out of 8 possibilities, right? So it's 3 over 8. And so on. So in general, the probability that x is less than a number, this is a random variable. X here is a random variable, while small x is a number, a dummy variable. Let us go back to the random variable definition. X, capital X, is a random variable, while small x here is just a number. So here, for example, if I want to ask you, what is the probability that x is less than or equal 1? What is the probability of x less than or equal certain number? Is the sum of the probabilities of all elements that correspond to x less than 1. So for example here, what is the probability of x less than or equal to 1? It's this plus this, right? Because x less than or equal to 1 means that it's equal to x equal to 0, صح? Plus probability that x equal to 1. Why did we do plus? Because x equal to 0, the event is mutually exclusive from x equal to 1. They cannot happen. If you have 0 heads, you cannot have 1 head, right? So they are mutually exclusive, and because of that, we added them. So the probability that x is less than a number, small x, a specific number, is the sum of the probabilities of all elementary events that satisfy this condition. Example, I will just to make sure that we understand. Now, what is the probability of x equals minus -8? In general, well, in this particular example, I will say, but then in general, can x be equal -infinity? -infinity means a very, very, very small number. By definition, the probability equals 0. What about x equals infinity? By definition, this goes to also 0. Okay. طبعا doesn't mean that x cannot take values at infinity or -infinity. X can take values. مثل Gaussian, مثل voltage, noise. You can have values that are very, very large. However, they probably because the uncompensate, the probability is can happen, doesn't mean the probability cannot be 0. Right, let's have more examples. Now going back to this, pushing the coin 3 times and marking the number of shades. This is our example here. So the probability that x is less than or equal to 1. This event, this is what we call it event. لكن الايفنت هذا ما عرفناه على السامبل سبيس. ما قلنا الايفنت في السامبل سبيس ايش كانت؟ تذكروا؟ What was the event? What did we? How did we define an event? Subsets. لا بصفة عامة. What is an event? It's a subset of sample space. صح ولا لا؟ Event A is a subset of sample space. Event مثلا A اللي هو 2 heads is happens when you have HHE, HEH, THH. صح? This is the event. These are the sample space elements that correspond to event equal the event of 2 heads. Now, similarly, you can define an event in the random variable. Now, this is an event, however, defined on x of s, defined on the random variable. On the random variable x, rather than defined on sample space. So instead of saying what is the probability of having 0 heads or 1 head, what is the probability that x is less than or equal to a number? 1. What is this problem? What is this event equivalent to? This is equivalent to the events, the union of events that gives you x less than or equal. What are these events? What are these values? X is less than or equal to 1 happens when you have 0 heads union with 1 head, right? 0 heads union with one head, right? 0 heads union with one head. So basically, you get basically 4 elements. So the event goes in the sample space. So this is the event defined where? On the sample space. Yes. So the event defined on X, you need, in order to find its probability, you need to find the corresponding event that is defined in the sample space. If I want to find the event that corresponds to certain, defined on certain random variable, I need to go back to the elements on the sample space that correspond to this event. Now, if this is an event defined on X, I can find its probability. I event في العالم, I can find its probability using the accent of probability, right? So what is the probability that X is less than or equal to 1? It's equal to the sum of the probabilities of the corresponding elements, because every element of them are into the sequence of the other, right? This is equal to the probability of one head, right? Union probability of probability of one head union what? 0 heads, right? And because these are mutually exclusive, you can write them as probability of one head, right? Plus probability of 0 heads, right? And one head is corresponding of the sub-events. You want this one, and this. So basically, again, you can write it in terms of this probability, you can write it in terms of this. Well, any questions here? All right, let's have another example. Make sure that I see. Make sure that you have the network working. If I see the case, I will not consider it. Right. Now let me ask you this. What is the probability that X is larger than 2? Well, can you note? Find for me what is the probability that X is larger than 2? Quickly, not other than 2. In order to find it, you need to find the corresponding event on the sample space. This is an event or what? You find where? In the sample space or the way? The random variable space, right? In order to find it, you need to go to the sample space and find the corresponding event and then find the probability. Do it as well. So half a minute. Easy. Okay. What? Yeah, how did you find it? Yeah, it's equal to the probability that X equal 3. And when does this happen? In the sample space? 3 heads, right? Which is only basically 3 heads. It's only one event. H, which is 1 over. Okay. Questions now? Sure.
It was order important. You have the training.
Not in the order. We're not saying pick or not pick. We are talking about pushing 3 coins and counting the number. We're not doing basically the sample space, which have 8, has all the combinations, all the possible outcomes with order, not order, and so on. So, what are the types of random variable? Now, if we understand the random variable as it's a mapping from the sample space elements into subset of the real line. ممكن ناخذ الريل لاين تاني. Okay, such that every element in the sample space is mapped into a single element in the read line, a single number in the read line. One element in the sample space cannot take more than one value in the read line. Okay. Now defining the random value in that way, then in order to find the probability of x less than a specific number or x equal a specific number, you need to go back to the sample space and find the corresponding equivalent event. And this already will be equal to that probability bracket. Now, understanding all this, let's talk about types of random variables. You can have discrete random variables. Means what? Means that the elements, the range in the elements that the random variable can take is basically a countable set on the real line. Countable ايش معناها؟ الانتجر زي integers, the natural numbers, real numbers, the set of 1, 2, 3, 5 up to 8, pattern, and so on. Okay, these are discrete random variables. So the SX here, in this particular example, in the cell discrete, must be is a countable set belonging to the real line. Countable set. I count it. Will give you a discrete discrete random value. Okay, so basically it can be finite or infinite, or it has to be a now a continuous, continuous basically can be, it is basically uncountable. SX here is uncountable. Set belonging to R. So R can be the random value can take any value in R. It can take any value from in the field from 0 to 2. Okay. And so. So for example, let us give examples. In the discrete, for example, this is our particular example, flipping the coin to current and not in how many values you can have? The random value, how many values it takes? 1 or 3. So basically 4 different values. It's countable and finite in this case. Selecting the number from a positive integer, the set of positive integers. Is it discrete or continuous? Discrete, because positive integers are basically discrete numbers. Number of cars arriving into a gas station. Just to be حطت بنزين. لاحظ number of cars arriving at a certain point in time. In this case, can you have 1.5 cars? No. Not good. Basically, it's 1, 2, 3, 4, and so on. Number of customers waiting in a line. Necessary. Number of customers have to be. So in this case, all these are examples of discrete. بينما continuous, مثلا temperature. You measure the temperature depending on how accurate you measure. It can take any value. Also the same, measuring the voltage out of cross resistor. It can take any value. طبعا هذا شيء أغرب يعتمد على accuracy if you're measuring device. However, at the end, it can take any value. Selecting a random number between 0 and 6. So basically, it can take, in continuous, it can take any value. Right? Please make sure that you attend. Mixed random variable is basically a random variable that takes values that are discrete and takes values that are continuous. So, مثلا, wheel of chance from 0 to 6. Okay. And مثلا selecting a number from 1 to 2. So basically, in this case, we get mixed random variable. The type is based on the event, not the sample space. So the sample space, it's not what decides the random variable type. If the sample space is continuous, still you can create a discrete random variable. مثلا you are measuring the temperature. What is the sample space? مثلا خلينا نقول من 0 إلى 50. يعني هذه all the possible temperatures. I can define my own random variable to be if it is above 25, it's hot. If it is below 25, it's cold. This is my random variable. You can define your own random. أنت ممكن تقول لي أنا والله بهذه السنة 3 أجسام أكثر من 35 هرت between 35 and 20 is moderate, less than 20 is cold. In this case, how many random variable? How many values it takes? 3 values. So it's discrete random value. However, the sample space was what? Continuous. So the type of the random variable doesn't depend on the sample space. It depends on how did you map the sample space element into. Okay. So basically, it depends on the event that you define. Yeah, temperature, sample space. What is the sample space? Sample space is the set of all possible outcomes. So of all possible temperatures in the which ranges from 0 to 50. Okay? So you can have any number. And I can define what I'm interested in, not in the exact temperature. I'm interested in categorizing it without interfering. وبعدين بكمل الشابتر بنمشي الشابتر what is the limit of every category. Category بالنسبة لي cold, moderate and hot. So in this case مثلا about 35 I will say it's hot. I will give it a number 2. Between 35 and 20 I will say it's moderate. I will give it a number 1. Below 20 I will say it's cold and I will give it a number 0. Okay. So my random variable has how many values? Possible values? 3 values. So it's a discrete random value. بينما السامبل سبيس ايش كان؟ Continuous random value. Continuous sample space. Okay? Now, in general, this is what I'm trying to say is that makes some mix. هذا يسمى a random variable, the type of random variable depends on the definition of the random variable. It is like we define it, rather than the sample space it's kind of different. طيب now شباب أي سؤال على random variable guys how what is the event in the sample space and the corresponding event in the random variable any question. Next you can have a random variable that takes values يعني مثلا خلينا نرجع للمثال هذا اللي كان فوق. Okay. Now here you can say هنا طبعا واضح من السكيل right? Okay. You can say مثلا in the next random variable let me say let me give you this example. A random مثلا with chance between 0 and 6. You can take any value between right? And I can define a random variable such that x, when s, so basically x equals xs, which is the random variable, equals 0, when s is this line, so belongs to 0 to 2. And it's equal to s for s belongs to 2 and 6. And sorry, 5. And then it's equal to minus 1 for s belongs to okay. And s equals minus 1 when s is between 4 and 6. So basically, I run the wheel, and whenever it stops, if it stops between 0 and 2, I would say that the random value is equal. If it stops between 4 and 6, I will say it's minus 1. If it stops between 2 and 4, I will give it the number that I use. In this case, the random variable clearly can take discrete values, 0 and minus 1, and it can take also continuous value between 2 and 4. This is a mixed random variable, where basically it takes discrete values as well as continuous values. The question can about this point. The type of the random variable ما يعتمد على sample space. ممكن sample space يكون continuous and yet the random variable that I define is هذا كان لا خلينا السامبل سبيس بدل ما ندرس كل شوي نرجع ونقول هيدز هيدز عارف ايش؟ cast it all into a number, specific number. الآن we will teach you how to play with this. هنتعلم حاجة اسمها distribution. And you will learn how to calculate the average, the variance, and so on. Without going back to sample space. هذه هي to make the probability theory more mathematical so that it's easier to manipulate. بدل ما كل شوي نرجع نتكلم عن السامبل سبيس. هي ما الغالب هو ما فانكشن من هنا وهنا. الآن بدل ما نتعامل مع السامبل سبيس بتفاصيلها لا حنصير نتعامل مع الأرقام. هذه okay? And we will show you that it makes more sense and it becomes easier to deal with probability. يعني نتعود عليها. طبعا ايش كان الموتيفيشن؟ الموتيفيشن أول شيء we want to get away from the details into numbers. ثاني شيء we will make most asset. ثاني شيء you will see later that there are already well-defined value values معروف. يعني people have encountered them in many places. Maybe your problem fits in one of them. This is why we start this real. We can find your problem fits within a well-known problem already. أهم الكورس هذا كيف توصل إلى الجسم. طيب لما نتعامل مع الأرقام إحنا جاء في ما يعرف كيف يسمى. لا استخدام الأرقام يعني ما يمكن to make it simple بس لكن at the end so this is an excellent question. Why we discuss all these things when I give you a problem you need to understand the physics. Like I said, how would you deal with this? يعني أنا أتكلم عن temperature ولا غيره ولا voltage ضرب process بعدين signal or whatever. You need to understand the physics. Why this behavior like this? لكن still you need to be able to deal with nothing. لما درسنا التفاضل والتكامل والاشياء هذه. التفاضل عباره عن ايش؟ يعني سلو رحنا في البدايه ايام ثانيه. طيب احنا we were able to find the slope when التغير في الصاديات التغير في الواي والتغير في الاكس نقدر نحسب التغير هنا التغير. طب اذا عندي فانكشن كونتينوس كيف نسوي التغير؟ we define what we call derivative صح ولا لا؟ why did we define the derivative? To simplify our work بدل ما كل مره نحسب الجيل بس اسوي تذكر التفاصيل. لا انا ما ابغى اسوي انا ابغى افكر. with simple rules with derivative rules association I will be able to find الميل حق ايضا. هل هذا معناه ان احنا نسينا المشكله الاصليه؟ we need to understand نفهم انه derivative is ايش؟ slope صح ولا لا؟ الكونتينوس slope للفانكشن. نفس الشيء التكامل. when you want to calculate the area under certain curve. اوكي لما يكون انا عندي كيرف معروف شو لينير ولا مربع ولا I can calculate it area صح؟ لكن if I give you a complicated solution how would you do it؟ فرحنا عرفنا التكامل. بعدين تكلمنا عن there are rules في التكامل صح ولا لا؟ there are techniques there are tricks. هذه الآن خلاص موجودة في مخك أنت عارف تسويها. مو معناه إنك أنت ما تعرف إيش المشكلة الأصلية. بس الشيء هنا the random variable is a mathematical tool that will simplify your life and will make you able to process and deal with it in a much more complicated way. واضحة يا شباب؟ طيب. Now let's define what we call the distribution function. احنا قلنا الكلام عن random variables at the end we need to deal with the probabilities. We need to deal with these random variables in a mathematical way. So one way to deal to describe a random variable is what we call the distribution function. طيب, let's give you what does this mean. What is the distribution function? So there are two functions that we need to deal with. We can describe a random variable with. A density function and distribution function. Let's talk about why, يعني integration behind this. Now let's go back to our example. This is given the current 3 times. Given the current 3 times, there are events in sample space. We map it into 0, 1, 2, 3, 5. Now, remember the total probability. What was the total probability in sample space? 1. Now, how is this one distributed among the different events? The sample space, كنا نقول إنه والله every one of them has 1 over 8, صح؟ Has 8 elements. Every one of them has a probability of 1 over 8. So basically, if I sum 8 with 1 over 8, I think can total. Now, if I go to the random variable and I ask myself, how is this total probability 1 distributed among the different values? فاحنا رحنا في الاكزامبلز اللي سويناها شفنا ان probability of 0 كم كانت؟ 1 over 8 because it's equal to the probability of the corresponding event. ايش كان corresponding event؟ K. 1 out of 8, so it has a probability of 1 over 8. بينما probability of 3 hits 3 x equal 3 كم كانت؟ 1 over 8 because it's the probability of the corresponding event of h, right? What about probability of x equal 1? 3 over 8 because the corresponding event has 3 elements h, صح؟ نفس الشيء هنا. Now, what is the sum of these probabilities? 1. Now you can visually see how is this probability of 1 distributed among the different values. Now you know that these two elements have higher probability than these 2 elements. Okay. So now you can visualize how this is distribution function. Basically, this is called what we call density function. So you can we will define now the distribution function and the density function such that we give this information. How is this probability of 1 distributed among the different values? Why is this important to us? Because this will help us know ايش outcomes which have the highest frequency, the outcomes that have or the highest probability outcomes that have this. So let's go and see how we define these distribution functions. Our function is the distribution function. So we this cumulative probability distribution function. C cumulative then distribution function, CDF. Okay, you will see this in many testing results. When I say CDF, it means the cumulative distribution function. I will say it's a function because it's a function of the value that x can take. ثاني شيء, it's a distribution function because it tells you how is this one distributed among the different values. ثالث شيء, it's cumulative because it's defined as this. خلينا بس أول شيء نشرح notation. What is this notation? This is f. F is the function. Denotes that this is a function. CDF. Capital F is CDF. CDF of what? The random variable x. Okay, so this is the CDF of the random variable x. More random variable y. What is it? What is W? Random variable x. So بس عشان نفهم النوتيشن. This is the function. This is the CDF of the random variable x evaluated at the number x. Dummy variable x. What does this function mean? This is by definition by definition, it's equal to the probability that the random variable x is less than the number small x. Okay? تذكروا اللي شوي الكلام عنها قلنا what is the probability that x is less than or equal 1, and we find this probability. Well, in terms of the CDF, this is equal to fx of 1. No, 1. Fx of 1. Fx of 1 means the probability that x is less than or equal. Okay? This is capital letter because it denotes the random variable. And this is small letter because it's a dummy variable. Or number. Specific number. واضح شباب؟ Now let's go to the flipping a coin. What is fx of 2? Diamond, when you see fx of whatever, which is a CDF, right? What does it mean? Diamond, go back to the definition. It's the probability that x is less than equal what? Probability of x less than or equal هذا الجزء جاء من الكونسبت of هذا الجزء less than or equal جاء لأنه it's fx. It's a CDF. 2 because this is the number 2. So fx of 2 is the probability that x is less than a number 2. Fx of 5 is the probability x is less than. Now in our example, using the coin 3 times, what is fx of 5? What is it? Pressing the coin and number of hits is random value. What is the probability that x is this time or equal? What is fx of 5? 1, because it's equal to the probability that x is this time or equal to 5. And we know that it's random value has to be this time or equal, because it takes only 0, 1, 2, 3 as values, right? Now, in order to find this probability, CDF at 2, it's equal to the probability that x is less than or equal to 2. And in order to find it, as you know how to find it, well, we go and find the corresponding events. X less than or equal to 2 happens, the equivalent events when x equals 0, or x equal 1, or x equal 2. So basically, the event x less than or equal to equals the event x equals 0. ايش؟ or معناها union, right? Right. X equal 1 union x equal 2. And because of that, we have, and what? How can you describe these events, شباب? Independent? What are these events? Mutually exclusive. Because mutually exclusive, we add. And this gives you fx of 2 equals 1 over 8 plus 3 over 8 plus 3 over 8, which is 7 over 8. طيب, let's see what does this mean. خلينا نشوف شكل الفانكشن. Now, why are we describing the function? Because we want to see how it looks, because it makes our life visually more easy. You can see things in a curve. So here, the same example, x 0, 1, 2, 3, and you can find that probability of x equals, we have found already probability of x equals 0 and 3 to be 1 over 8, probability of x equal 1 and x equal 2 is 3 over 8. So now, in order to find the cumulative distribution function, CDF, we find fx of 0. What is fx of 0? It's the probability that x is less than or equal 0, which is probability of x equal 0, which is 1 over. What is fx of 1? It's the probability that x is less than or equal to 1, which is equal to the probability of x equals 0, probability زائد probability of x equal 1, which is 1 over 8 plus 3 over 8, it's half. What is the probability that x is So what is fx of 2? Similar. Fx of 3. What is fx of 3? 1, because it's the probability that x is less than or equal to 3, and it happens always. It's 1. So now let's sketch this. Right. So what we are sketching here is fx of x versus x. وهنا هنتكلم fx is the random value x of the number, the dummy value of x. Now when x is negative, what is the value of fx of minus 2? 0. Why? Because it's equal to the probability that x is less than or equal to minus 2, which cannot happen, which means I am equal 0. So clearly you can see that this function equals 0 until we reach 0. When we reach 0, fx of 0 صارت كم؟ صارت كم يا شباب؟ كانت 0 قلنا right until we reach 0 it becomes 1 over 8. So it's open here and closed at the 1 over 8. What about fx of 0.5? What is fx of 0.5? Fx of 0.5, what is it? It's 1 over 8 because it's the probability of the corresponding event, x less than or equal 0.5, which is equal to the probability that x equal 0, which is 1 over 8. And this stays until 1 over 8. نفس الشيء للمسألة. What is the fx of 0.9? 1 over 8, right? fx of 0.99. fx of 0.9999999. Until now, I did not reach 1. So it's open here. And once I hit the 1, هيتغير الإيفنت. fx of 1 يصير مختلف. fx of 1 is probability that x is less than or equal to 1, which includes x equal 1. Now, so it's open here, closed here. And the value of fx at 1 equals. Now, similarly, what is the fx of 2.2? Half, صح? Because it includes the same events. fx of 2.9. Still, we are here. We are including the same events because it's probability that x is less than or equal to 2.9. And yes, and continue. Sorry, 1.9. Sorry, it continues like this until we hit 2. When we hit 2, there is another event that was included, which changed the value of the event, which changed the probability. The probability صارت كام? 7 over 8. And this is closed here. Okay? And now the same thing. You can ask the same questions. Probability of fx of 2.7. It's 7 over 8. Until you hit, and this opens, until you hit what? 3, it becomes 1. After 3, if I say fx of 2, fx of 9, it's 1. It will continue 1 forever. It is 0 before, it is 1 always. It's 0, at minus infinity is 0, and at infinity is 1. Okay? So next time, inshallah, that's one thing that I want to mention here, and before we close. If you see the jump here, what is the jump at every step? What is this 3 over 8? It's the probability of x equal 1. This was the probability of x equal 0, and so on. This is equal to probability of x equal 2. So the jump, the amount of jump is equal to the probability of that number at which you jump. Next time, shall we go into more details and we describe the density function. So don't forget the quiz next time, inshallah.